All right, welcome everybody. My name is Michael Mastalio. I'm with Urban Engineers. I'm going to be moderating our Innovative Interchanges session. We have 3 presentations today and 4 speakers. The first presentation was called Projects at the Edge, Case Studies in Being First, presented by Smith Siramaskel. He's with HDR and he's a principal professional associate with HDR and leads HDR's concept development practice group. Smith has 20 years of experience split between roadway design and traffic analysis and simulation. He's been involved in planning, design, and construction of numerous innovative intersections and interchange concepts. Our second presentation will be contrasting challenges and solutions of 2 Pennsylvania DDIs. Dave Hamlet is co-presenting with Dave Kozel. Dave Hamlet is a PE with the highway section, and he's a highway section group manager and VP in Gannett Fleming's Camp Hill office. He holds a bachelor's degree from Rensselaer Polytechnic Institute and a master's degree at Penn State. He has 28 years of design and management experience in highway projects, and he's a registered PE and PA. Dave has served as the PM on the I-83 Exit 4 improvement project in York County, which is currently in construction and scheduled to be completed in 2021. Dave also gave me scheduling training. Dave Kozel is a PE and the highway group manager and senior project manager at Gannett Fleming's Pittsburgh office. He has over 34 years of diverse experience in the design, development, management, and oversight of transportation projects. Dave received his bachelor's degree from Point Park and is a registered PE in Pennsylvania. He serves as the project manager on the completed I-70 Route 19 DDI project in Washington County. Last but not least is Gil Schwelicki. He's our last presenter, and he's going to be, his topic is PennDOT DDI peer reviews, lessons learned beyond the guidebooks. Gil is an internationally recognized expert and leader on DDIs and other innovative intersections and interchanges. Gil introduced the DDI concept to the transportation world in 2003 and has studied, developed, and designed DDIs for almost 20 years, along with other innovative geometric designs. He has given presentations, workshops, and as well as assisted on DDIs and other innovative designs in the US, Canada, Australia, and several European countries. All right, with that, I'm going to turn it over to Smith, and Smith, take it away.
All right, hopefully you guys can see my screen. I apologize in advance if I talk really, really fast, but I got a bunch of cool stuff to show you guys today. Do go ahead and bombard me in the question and answer dialog box, and I will hit up every single one of those as I can, if not during this presentation, then after. So what I want to start with are a couple of projects. I'm going to weave in a couple of case studies, and basically what I'm going to do, if you've seen me present before, a little bit something different this time. I'm going to tell you all the places where I've screwed up in the past. So this is going to cover a lot of lessons learned from planning through design, all the way through implementation. And I'm sorry if my camera is now pointed over my head, but I'm going to be doing some drawing, so that's kind of unavoidable. But anyway, what I want to point out first is what you see on the screen right now. This is the University Parkway DDI in Sarasota, Florida, I-75 and University Parkway. It is the largest DDI on the planet at this time. It's got a total of 12 lanes in the interchange core, and the old interchange here used to be a standard diamond, and to put this in perspective, the dual left turns at this diamond used to have storage that went back 4,200 feet in each direction. That's how much volume was trying to get on I-75 at this point in time, and that actually comes into play in a little bit latter portions of this story. One of the first things I want to say is make sure you choose the right software. The original concept that was developed for this interchange was done using simple synchro analysis, and they to say the very least, the number of lanes that were going to be needed here far exceeded what was proposed as part of the original base design. The final design concept was done using VISM analysis. Not to say that VISM is the only tool, but you really need to look at microsimulation. And the reason for that is that lane utilization coming through the interchange, coming through the crossovers, how they interact with adjacent intersections, how they're fed by adjacent intersections. All of those play a role in how you need to lay out your interchange. Make sure that you look at a big enough picture, because the stuff that's right next door will often change how your project needs to be designed and what it needs to be accounted for. Now, this is the I-85 project. This is a DDI that I put in the ground back in, I think, 2012-ish or something like that. This was the first one that was completed in the state of North Carolina. And what I want to point out is that there was a full access intersection that was located pretty much right here. And no matter what interchange you were looking at, if you were looking at a single point, if you were looking at a diamond, whatever the case may be, the presence of this intersection was going to be a problem. There is also a very, very heavy movement that wanted to come back this way and either head south on 85 or north on 85. And having that extremely limited space in between the interchange and that intersection was going to be problematic. So for this project, not only did we look at this intersection, which was in the scope, and the ramp terminals, which was also in the scope, the way we handled that movement ended up creating an extension of our project limits off to the west. And basically what you have here is a partial R-cut, or restricted crossing U-turn. Although at the time that we put this in, that really wasn't an acronym that was widespread or well known. This is a mistake that we made in Utah. What you're seeing here is the east leg of an intersection. I forget exactly which one, but this is on the I-15 core project. We worked on this, I think 2013, 2014, somewhere around that area. But what I wanted to show you is this. Once this was open to traffic, you had 2 lanes coming out of the DDI, and you had a 3rd lane coming off of the ramp, and you had enough width in here for a 3-lane section. And what they did originally was they ran this as an add lane that continued on down that road. The problem is, if you look at this from a geometric perspective, this curve coming off of the main line, it doesn't really reach its point of tangency until you get a little ways down that section. And this curve coming across the ramp, it also doesn't reach its point of tangency until the lanes have actually merged. This driveway became problematic because what would happen would be people came to this point and they kind of cheated the end of this section because there wasn't a physical barrier or anything like that. It was just paint. So they would kind of drift across and hit that intersection. So we were seeing a lot of sideswipe accidents at that location. That was something that was later mitigated through some additional signing and striping. But the gist of it is we're really not going to do anything like that again. Now, if your project is limited to the interchange itself, that's not to say that that gives you the excuse to not look at anything outside of the bounds of the project. In our case, in this location, this is I-25 and College Drive in Cheyenne, Wyoming. This is far and away the smallest DDI you're probably going to see. It used to be a 4-lane diamond. It was converted to a 2-lane DDI, and our project limits were very, very strict. We could not modify any of the driveway radii that are located at those 2 points, and we needed to maintain the existing bridge, which is located here and here, and basically we just had the section in here to mess with. Now, what I really want to point out about this is, okay, we were told we couldn't mess with those driveway radii. However, if you look at the way the driveways work, you have a McDonald's over here, and you have truck stops in the other 3 quadrants. You know that there's going to be a lot of traffic coming off of this interchange and accessing those driveways, turning left, turning right, what have you. This is the cheapest location to get gas along I-80 in the state of Wyoming. And during peak periods, this has 55% trucks, massive amount of truck percentage. So if you look here, for example, we had the capability to have 2 lanes going away from the interchange. We had the space because you only have one coming through the core of the interchange. We could have made the right turn coming off of the off-ramp. We could have made that an add lane. Instead, on both sides, we intentionally pinched it down so that right here and right here, you're down to a single lane. It doesn't really have that much of an operational impact, but what it does is it ensures that right here in this very, very limited section here and this very limited section here, you don't have any weaving conflicts with trucks that are coming in from the right and then needing to go to the left, et cetera, et cetera. So this is an instance that I want to demonstrate, or that I want to get the point across, that what happens outside of your study area, what happens outside of your limits of construction, in some cases, will absolutely drive what you do within your limits of construction. So just because it's out of your scope doesn't mean you can just forget about it. Now, when it comes to public involvement, there's always this fear that, oh my God, you're driving on the wrong side of the street, everybody's going to die, my constituents are awful, what have you. What we found in the DDI implementations that we put in so far, the fear of how the general public was going to receive it was far, far worse than how they actually received it. What we have done is we've gone out and made sure that in a lot of these firsts, they involved showing people, and then oftentimes it was showing agency staff, it was showing elected officials what it would look like from the driver's perspective. And instead of a normal public information campaign, it was almost more of a public education campaign. And that was something that what you see on the screen on the right side, this is a YouTube shot of what is FDOT's single most viewed video ever on YouTube. And as of the time I grabbed this screenshot, we're looking at just over 1.1 million views. A couple of different things that we went out of our way to do on this interchange. We had quarterly update meetings, and we invited college students, engineering college students and high school students to attend these to really kind of get a behind the scenes look at what it really takes to engineer a project and get it into the ground. We used a lot of heavy social media presence on Facebook, on Twitter, had a project website. At the public meeting, we had two different things going on. Number one, we had a station where you could grab a hold of a wheel, had pedals, and you could drive through a 3D rendering of this DDI. That did not get as much attention as a giant, and I'm talking massive, like 8-foot long plot of the DDI interchange at University and a pile of Hot Wheels cars that people could actually just manually trace through the interchange. That seemed to be the focal point of our public outreach, and people really, really like that. Now, here's the big catch. You need to have staff that's going to be knowledgeable up and down the entire chain, because everyone that people see out in the field, they're going to get asked, what are you doing? How does this work? Et cetera, et cetera. So really early on, we realized we needed to create talking points that pretty much everybody up and down the chain involved with the project was aware of. And we went so far as to actually have a designated area off to the side of one of the quadrants that was set aside for media interviews to kind of showcase the elements of the DDI that we really wanted them to showcase when it came to on-the-spot hits for just your local news and things like that. Now, hopping to a different location. Here's something that I wanted to talk about that came up, that obviously didn't come up here in Florida, but may pertain to pretty much everybody in the northern tier of the U.S., or any place where you have a need to go ramp to ramp. A DDI basically, by its very nature, pushes traffic that comes off the ramp to the right or to the left. But there are instances, for example, if the bridge has insufficient vertical clearance, where you're going to want to provide the capability for somebody to go from an exit ramp to the entrance ramp. Now, the particular example that I have on the screen right now, this is from Minnesota. And what happens here is the city controls the crossroad. And the DOT, the state DOT, is responsible for snow maintenance on the ramps and on the freeway. So what you see here is that we built a little pocket down here in the southwest and the southeast quadrant. Off to the west, they had a different way of navigating that, and there's actually like a maintenance facility they could get to, so we didn't need to do this on the other side. But here, for the northbound to northbound movement, we built this little oversized pull-off that's going to be colored different than the rest of the pavement, et cetera, and then we built a mountable curb here, a depression in the island right here, and a mountable curb here. The reason that we did it in that direction was to make it extraordinarily counterintuitive or nearly impossible for a member of the general public to accidentally make this maneuver. This distance right here, if you look, there's actually an auto turn template that's in there. And right in this location, we actually modified the alignment to pull the two directions far enough apart to perfectly store a snow maintenance equipment inside that median to allow that traffic to go from ramp to ramp when they're actually engaging in snow maintenance activities. So a lot of those little things, this is another one of those things where something that we don't typically think about affecting design had a significant effect on the design, because we did have to change the alignment in order to make those accommodations. In construction, one of the things that we did for University Parkway, very, very heavy social media presence. website presence. And when we were at the public meetings, we collected phone numbers and we texted people updates on MOT changes, design changes, detour changes, and things like that. One of the things that we noted right off the bat, and you can kind of see it here. I'm going to highlight a couple of these lines right in here. These lines all through here were remnants of the existing diamond striping. And during construction, that made this core of the interchange quite confusing because you still saw the old stripes in there before they were able to lay everything over and get rid of the temporary striping. So it kind of created some complications. It's just something that we did not think about necessarily when we started laying out the MOT for this. Now, post-implementation, there are a couple things that I want to point out here. Clearance time controller issues, you can kind of see the outline that we're talking about there on the left. Now, timing issues. One thing that I want you to call attention to is when the through traffic gets released, the turn traffic in this case gets released. And that'll happen here in a moment where the traffic coming from right to left is going to get its green. And there you go. That right there should not happen. Now, what happened here is that the through movement got released, the left turn coming off the off-ramp got released at the same time. Now, the reason I say that that should not happen is when you are calling attention to your yellow, when you're calculating your yellow and your all red time, you're really trying to calculate it from this point over to this point to make sure that cars can get through that. However, if you include this as part of your all red time, all of a sudden you're really decreasing the amount of efficiency that you have because you're increasing the amount of lost time that signal is going to need to deal with. In reality, what you want is this guy right here, the through traffic, to get that green a little bit earlier than this because you want to delay and you want to trail that signal phase. The reason that it was not done here on University had to do with incompatibility with the controller software. So make sure that you account for little things like that didn't even occur to us until we put this stuff in the ground. So the way you're looking at University right now, and this is incidentally also running in sync software along the corridor in real life, make sure that your signal controllers are capable of doing some of the delay and trail green features that you really need to have updated when you're running this kind of interchange. Now, the other thing that I want to point out here, stop bars for the ramps are located here and here, which means these signal phases or these signal heads are facing this direction. If you are coming down the ramp, you do not have visibility to those signal heads until you've already gotten to the midpoint of the turn. So realistically at this location, what should have been put in here are auxiliary signal heads looking down the ramp so people can see them. Now, when you put in auxiliary signal heads, make sure that regardless of whether or not you can see both the right and left, if you're going to put in an aux head for one, you need to put them in for both because the DDI is the only interchange type where depending on which way you're going to turn, there is never really going to be almost never going to be a situation where both of those heads are showing the same indication. And you don't want a driver to get confused as to which one is green, which one is red, et cetera, et cetera. Overhead sign placement. What I'm going to show you here is that we mounted the overhead signs on the near side of the freeway crossing. When you get to, if this DDI is over or it's under, it really doesn't make a difference. I recently peer reviewed a DDI where they put the overhead signage on what would have been the back side of the core of the interchange. And one thing that they did not check, which ended up being a fatal flaw in that design, was it precluded somebody from being able to get visibility to the signal heads at the crossover intersection. Now, I do see questions rolling in, and I will answer those separately, but as you can kind of tell, I'm trying to move fast to fit my stuff within 20 minutes. So I will get to that question about Synchro and Vista. Now, this is an example of one other place where we screwed up. This is a mistake that we made very, very early, and in some cases, in one case, this is actually a change in standards that would not allow us to do now what we did then. And that change in standard has to do with this. The PED push buttons for both directions, for both the crossovers here and here, are placed on the same pole. Based on new ADA guidelines, those need to be placed at least 10 feet apart on different poles for audio cues. So that's something that we can't do anymore. It's okay that this crosswalk is perpendicular to the direction of travel. What that does is it minimizes the crossing distance that you have here. This crosswalk, however, this one really should have been bent a little bit more so it came across like this. So you could get this stop bar a lot closer to your point of conflict. So what I just drew there is the path the vehicle in the other direction would go through that crossover section for a DDI. If you look at where this stop bar is placed, that is a very, very large distance for you to come to a stop or to realize you're coming to a stop. If you think about how you drive a traditional intersection and there happens to be snow on the ground or you can't see the pavement markings, you know where the crossover conflict really is, and you're kind of expecting that there will be a crosswalk before that crossover and a stop bar before that crossover. So if a driver comes here and he can't see pavement markings, he's kind of expecting to stop somewhere around here, not as far back as we have them. So when I went out to this particular spot, and this is in Concord, North Carolina, I noticed a number of locations. Notice that this right now is getting the green. Almost every third phase, we saw a car stopped well beyond the stop bar, well beyond the crosswalk, and kind of in space. So that is a lesson learned that we would not repeat on an interchange like this. Going to the bigger picture, this is University Parkway. This is what it looked like before construction. There's a lot of commercial development up here, a lot of commercial development up here, and a giant regional mall down here. The locals had it in their heads that the interchange itself was the real bottleneck. When we ran the analysis and looked at everything and we cleaned it up and we made this a DDI, this is what it looks like today in the ground, we tried to tell them, you have other issues that you need to deal with. And when we ran the analysis, in the previous studies, this is what they thought they needed to do out there. I'm not going to trouble you to count all the lanes, but coming from here to here, you're looking at 14 total lanes from one side of the road to the other. So their approach was to simply throw lanes at this problem and hope it would go away. When we ran the analysis in VISIM, we found that even in 2028, so just before the year of open, you were looking at 1.5 minutes of average delay per vehicle. By the time you got out to 2038, you were looking at almost 3 minutes worth of delay per vehicle. And this is for the simple, just keep it the way it is, throw lanes at it and hope it works. It took us a long, long while to come up with a potential fix for this location, but you can see here, basically involves a partial DDI and a lot of other creative little shuffling of different bits and pieces. And hopefully if this video or if this presentation is going to be saved, you can go back at your leisure and stare at this diagram until it makes sense. But the message I want to take home from it is we got the level of service down to LOSB, even all the way out to 2038. But we tried to tell them, if you don't fix this, it is going to be a problem. Today, it is a triple left turn that they've put in for that. It is a triple left at a standard style intersection. The storage bay length is around 2,700 feet, and it overruns almost every single cycle during the peak period, during the PM peak period. Off to the east of the interchange, what you're looking at here is the intersection with Market Street. And again, the previous study had gone in and they'd said, you know what, throw enough lanes at it, we can make it work. The average delay based on our analysis in 2038 was going to be roughly 4 minutes. So obviously it wasn't going to work, and their level of their amount of storage was simply insufficient. What we recommended to the county at the time was to go with something like this. This is just a straight up R-cut. And we managed to get or show that the level of service could drop into the B's and C's if they did that. Now, here's the thing that I forgot to mention. The interchange belongs to the state. The intersection to the east belongs to Sarasota County. The intersection to the west belongs to Manatee County. And nobody wanted to pony up any extra money to fix their intersections, which is why the DDI became the DDI and why the adjacent intersections were left alone. The county has come to realize that this intersection improvement is necessary, so they've gone ahead and started this one well into design. The intersection off to the west is still a train wreck that we kind of expected it to be. This is how it runs. This is obviously not the peak of the peak hour. It is pretty bad because you can see a congestion northbound on I-75, but this is the University Parkway interchange about 1 month after construction. You can see my contact information up there in the upper left. I am right at the 20.5-minute mark, and I see a whole slew of questions up in the Q&A section. So I will start attending to those, and thank you for your time, and thanks for the invite to talk.
Thanks, Smith. That was great. Lots of good information, lessons learned, and best practices there. I'm sure there's a lot of questions that you'll have some time here, but hopefully you get to still watch Dave and Dave's presentation. All right, guys. Dave Hamlet, do you want to kick us off?
Yeah, that sounds good. And I will start by turning it over to Dave Kozel.
Thank you, Dave. Dave and I are going to go through the contrasting challenges and solutions for two PA diverging diamond interchanges. Before we get started, we'll do some overview here, but we'd like to apologize because this presentation could probably go a lot longer. So we're going to go over some information, but it'll be abbreviated. We'll just briefly describe what is a diverging diamond, and we'll go through the I-70 US 19 Washington County, PA, the first DDI constructed and opened in PA. We'll do the I-83 PA 851 Shrewsbury, PA, the second DDI that will be open. We'll do some geometrics, traffic control discussion, traffic signals, access management, stormwater management, public involvement, and some aesthetic features on each. The first, what is a diverging diamond? The previous presentation really gave you an idea. It's a diamond type interchange. The roads within the interchange, beneath or above the interstate, are crossing over to the opposite side. What this does is facilitates movements to and from the ramps and actually reduces the number of traffic signal phases. One of the major advantages you'll find is the left turn movements to the ramp. If you see in a diagram, they're a free flow movement. They are not controlled by the traffic signal at the intersection. The first project we'll talk about is the I-70 Route 19 Washington, PA DDI. The final design team was Gantt Fleming and Tri-State under the Department of Transportation, and the prime contractor was Golden Triangle. There was other team members, but we apologize if we couldn't meet everybody on here. The one thing everybody can do is there's a website for I-70. It's www.i70projects.com. This project and other are on there. Just to give everybody an idea what the existing condition looked like. It's a substandard cloverleaf built in the 1960s, substandard, and it had short weaving sections and substandard XL, decel ramp lengths. It had extremely high crash history. As you can see in the picture, a lot of commercial development all around the interchange, car dealers, Home Depot, Walmart, Sam's, and so on. Heavy commercial development right up against the right of way. Traffic in 2014 was about 70,000 cars a day with heavy truck percentages. And on Route 19, it was 28,000 a day. The solution obviously came down was a diverging diamond interchange. That diverging diamond interchange actually allowed the existing bridges carrying I-70 over Route 19 to be maintained. Even though we redecked them and did some grade changes, those bridges stayed in place. Those were dual 3-span bridges. Also, the diverging diamond allowed us to reconstruct the interchange within the interchange footprint, which minimized right-of-way impacts. In fact, the whole project itself, I believe, had 8 property impacts. They were all strip takes, no displacements. This project also widened I-70 from 2 lanes to 3 lanes and included a 4-lane section in each direction between this interchange and the Route 136 interchange just to the east. One of the challenges with this diverging diamond interchange was the grades and the curvature on I-70 and Route 19. As you can see in this picture, I-70 was on an upgrade about 3% from west to east, and Route 19 was on a 3 to 5% upgrade through the interchange from south to north. And those curvatures came into play as we designed this interchange. Go ahead, Dave.
Our second DDI that we're going to compare and contrast is I-83 and 851 in Shrewsbury, Pennsylvania. It is currently under construction. Prime contractor is Kinsley, and the design team with Gantt Fleming was Whitman Reckart, Sakanis, Stell, Susquehanna Civil, and Wallace Montgomery. And as just like the I-70 project, it does have its website, which is shown on the slide. The existing conditions, we had a tight diamond interchange for an existing condition, and similar to I-70, a lot of commercial development immediately adjacent to the interchange. The traffic on I-83 is about 53,000 vehicles per day. And on the crossing street, pictured down below, PA 851, about 19,000 per day. The overriding purpose of the project was to correct the safety issue with the ramp backing up onto I-83. As you can see, it's getting close to doing that in the top picture. And down below on the side street, there were also some driveways that caused congestions and safety issues as well. With it being a tight diamond, 3 lanes, so it had a center left turn lane. And as you can see, it doesn't take too many vehicles, especially large vehicles, to clog up the interchange and cause congestion issues. And the geometrics did not accommodate large vehicles. Now the solution, our DDI solution here, the I-83 bridges were replaced, and that allowed the crossing road 851 to be widened to 2 lanes in both directions. And just like the I-70 project, the footprint of our DDI in Shrewsbury stays within the existing footprint, with the exception of the widening along 851, which did cause 1 business displacement. So as Dave mentioned, first we're going to talk geometrics and compare our 2 interchanges. And so for the I-70 DDI, there's 1,100 feet in between crossovers. And that really allowed for a few different things to happen. First of all, it allows the median island to be tapered back down to existing conditions through the majority of the area between the crossovers. This allows then the existing bridge to be saved. They were rehabbed instead of replaced. And by having a narrower median, pedestrians are accommodated on the outside, on the shoulders, and then there's crosswalks through the crosswalk area. To contrast, on I-83, there was less than 300 feet in between crossovers. And so the median island stays full width in between the crossovers. With the median island wider, that means the bridges need to be replaced. They cannot just be rehabbed. And it makes sense at that point to route the pedestrians through the median of the DDI rather than along the outside. Now, going back to I-70, as Dave mentioned before, US 19 is on a curve. And because of that, the entire roadway is sloped at reverse crown. So really there's no difference to the driver in the before condition to the after condition. It was not curbed in the before condition, so the proposed was not curbed either. Contrasting that with Shrewsbury, I-83 exit 4, 851 is generally tangent. And with there being slower speeds through a DDI, this one was designed for around 25 miles an hour. The pavement was sloped from 2% at 2% from the median out towards the shoulder, which would normally mean normal crown, but with traffic on the opposite side of the median through the DDI, it ends up being reverse crown. The existing condition was curbed, and so that was kept through the proposed. And now to some similarities in geometry. The crossover angle was very similar between the 2 DDIs, as was the crossover tangent length. In both DDIs, the bicycles were maintained along the right shoulder, which ends up, of course, being the inside shoulder through the DDI. And in both interchanges, there were dedicated turn lanes, either to or from the ramps where traffic volumes warranted. Back to you, Dave.
I will start going through some other things to contrast these. Traffic control for an implementation of the DDI in any interchange is important, and I'll go through each one. On the I-70 US Route 19 project, with the traffic volumes there, we basically had to maintain 2 lanes of traffic in each direction on both I-70 and Route 19. We had no ramp closures during the phase construction. During the phase construction, we actually went through 4 different interchange types. The first was the existing cloverleaf. Then we went to a temporary trumpet using the western side of the interchange. Then we went to a long-term temporary diamond interchange, then to the DDI interchange itself during construction. In September 2016, Golden Triangle implemented the DDI while it was under construction. And if you look at the photo in the upper right, you can see traffic that went into the DDI. It's kind of like you have to implement the DDI to finish it. You can still see in those island areas, the old diamond temporary ramps were still in place when this picture was taken. But at the same time, in the lower right corner, you can see the traffic, all the traffic was on the eastbound side of 70 while the contractor was still working on the westbound. So this interchange was implemented during construction. On the I-83, it was a little different. One of the critical features was the bridge over 851. That bridge was over widened so 2 lanes could be maintained in each direction at all time. In the end, that bridge will be able to handle 3 lanes directional in the future. One of the things that the contractor will be doing on this one, similar to Route 19, the DDI will be implemented at overnight shutdowns, which was a lessons learned from the US 19 project. Traffic signals are another important component of the intersections. As Dave mentioned, the distance of the crossovers on the US 19 allowed for 2 controllers to be used, one on the north and one on the south. The tight spacing of the crossovers on 851 Shrewsbury on that intersection will only had 1 controller. And that's something you definitely want to coordinate as you develop your DDI, whether it's 1 controller or 2. Access management is another component. On I-70-19, most of our access management was during construction as Route 19 was reconstructed primarily within the interchange limits up to the adjacent intersection. One of the only things we had to do was we ran a detour for what you see on the picture there was for a left turn onto a side road, which was a car dealer. We ran a detour to the south and came back. But most of our construction was within the interchange area. On Shrewsbury, as Dave mentioned before, there was 1 displacement. There was also a consolidation of driveways in order to remove a driveway that was closest to the DDI. So this project actually had a little more involvement with private properties adjacent to the interchange than the I-70 did at 19. Stormwater management, another component that's important. On I-70 Route 19, we basically minimized impervious area by designing a detail within the cloverleaf. We did end up with 3 stormwater management basins, primarily for some of the increase of impervious for I-70 to 3 lanes, but we did have to include 3 separation chambers for water quality, primarily in the lower left corner of that picture, which is a basically special drainage structure for water quality. Maybe a little bit of difference on the Shrewsbury 851 was that it was a tight diamond with steep infield areas and limited room for basins. The design included vegetated swales, bioretention basins, and an impervious basin. Part of this was located within a public water supply. Primary purpose was to mitigate for the over widening of I-83 bridges and the wider footprint of 851. Go ahead, Dave.
All right, as far as public involvement, it was similar for both projects. Both projects had public meetings and project websites. Now for that I-70 US 19 project, there was a 3D visualization that was done to show people what it would look like to drive through that DDI. And that same video was then used later on the I-83 Exit 4 projects. Use the same video. And turning to aesthetics, out in Washington, PA, US 19, there is colored concrete, as you can see in the top photo, along with the River Rock infields. And then the infrastructure color, the overhead bridge, was made to match that. In Shrewsbury, with this being the first exit, coming into Pennsylvania, or in Pennsylvania, coming north from Maryland, PennDOT wanted to have more of a welcoming statement. So it involves putting in a flagpole, a curvilinear dry stacked terrace walls, and some tiered plantings. Those were partially financed, and they're being completely maintained by some of the local municipalities and civic organizations. And so consequently, they're going to be recognized on a beautification acknowledgement sign. The bridge will have some painting on it as well. And underneath is some steel artwork. There's a Liberty Bell, and there's script writing that says life, liberty, and the pursuit of happiness. And in addition to these, there's some wildflower plantings as well through the interchange area, again, just to make a nice welcoming statement to people coming from out of state. And this photo shows us the completed DDI in Washington, Pennsylvania, I-70 and US 19. And this photo is the most recent one we have for I-83 and PA 851 at exit 4 in Shrewsbury, Pennsylvania. This is scheduled to be completed next year. So as you can see, two projects, separate parts of the state, a lot of similarities and a lot of differences. Thank you.
All right, that's great. Thanks, Dave and Dave. Does anybody have any questions for the Daves? All right.
Smith is answering one right now.
Okay. All right. Well, let's get Gil going, and then if we have time at the end, we can always answer. But feel free to respond in the chat or in the Q&A if you don't mind. Okay, Gil, you're up.
Thanks, Mike. You see my screen?
Yep, you're good.
Awesome. All right. So I'm going to try to leave a couple of minutes at the end. The good thing is that because I had two visitors before me, they did such a great job, I might be able to reference them beforehand to save a minute or two. So what we're going to talk about here is the some of the PennDOT DDI peer reviews that we've done and the lessons learned beyond the guidebook from these peer reviews. Is it going? Is it?
Not yet.
Why is it going forward? All right, there we go. All right. So the Federal Highway DDI Virtual Guide is a great resource to getting started in DDI, but there are many limitations. DDIs are viable options in more cases than described in the guidebook. It was developed in August 2014 when there were only about 12 to 18 DDIs in operation. All it discusses the optimal conditions, and in some cases, the geometric guidance in the guide is too strict, and while in other cases, there's not enough guidance. So many questions are not answered. And so when you're working on your first DDI or even your first few DDIs, the guide is a great start, but it's not going to answer all of your questions. So here you see the starred locations in yellow are the DDI projects that we have done peer reviews, and then the one in green, the one in orange are the two DDIs that the Daves mentioned in the previous project, in the previous presentation. The presentation talked about the first DDIs that opened today, so we don't have to do it this side. So the first DDI DDI review that we did was, or that one discussed, is the one on the left, which is the I-70 SR51 in Southwest Pennsylvania. The problem here is mainly a safety problem. 70 is below standard, as a below standard cloverleaf, and so they need a new bridge over here, and DDI seem to be a good solution over here for safety and cost. The one on the right is a DDI that's being proposed at US 422 and Penn Street, where it's a very urban cloverleaf, even though the cloverleaf itself doesn't seem urban, but to the east is downtown Reading, and to the west is commercial district in West Reading. And this is a very interesting location because you have these constraints To the east with the railroad cross, I'm sorry, to the east is the river crossing, and to the west you have a road crossing. So we have this alignment issue combined with these constraints at the east and the west, and we got to fit in a DDI in this location that has capacity issues and pedestrian volume as well. This project here is the US 22 Broadcasting Road location that is just northwest of Reading. And here, we have development that's coming into the southwest quadrant that requires more capacity here. And you have, again, constraints where you have this bridge that needs to remain. You can't touch the bridge, and you only have limited room underneath the bridge. And then you, to the northwest and the southeast, you can't touch those quadrants. The northwest is a commercial strip, and to the southeast is the Penn State Satellite Campus. So you got to fit this in a very tight location over here. And at the same time, because pedestrians and cyclists are going from the campus to the shops in the northwest, you need to make sure you're adding pedestrian and bicycle accommodations. This is the US 22 Pennsylvania 145 project just north of Allentown and Whitehall. In 2012, you see in the picture in the upper right that it used to be a kind of funky cloverleaf, and they made improvements over there, making a partial cloverleaf. But now, with a new bridge, but now 22 is being widened, and we need to convert this. We're hoping that we could convert this to a DDI and be able to use the auxiliary lanes for the loop branches to make them into through lanes for the widening part and be able to save the bridge. And there are congestion problems with Diamond or DDIs potentially. We're talking about during the PMP coming from Allentown, also during the holiday and weekend traffic going to the mall in the northeast. And again, we got to save that bridge. We must. That's a concern we must deal with over here. And then this project is the 33 William Penn Highway project in Bethlehem, just to the side of Easton, where we have development happening on both sides. Again, we need to fit everything underneath the existing bridge, and there's significant traffic being generated to the northwest quadrant. That's a parking ride lot to the northwest over there, and there's going to be more development to the north. So we've got to figure out how we can get us all to fit within some tight constraints. So when we're doing these peer reviews and we get these projects, there's a lot of things that can't be answered in the guide, and that's where we're going to spend pretty much the rest of this presentation on, is all these questions. Now, the good news is that there should be a second edition of the DDI informational guide coming out very, very soon. I was really hoping it'd be published by now, but it's not. There are actually preliminary chapters for the operation that was published in 2019. If you do a Google search of NCHRP 03-113, you can find it, or do other Google searches as well. But soon there'll be some ped bike and geometric design chapters that are published, hopefully within a very short period of time. So let's go through some of these questions. First, can the DDI actually work operationally? The answer is always yes, but it's kind of a trick question. Is that I can always add more lanes and make it work, but when you add constraints, then that's your real question. Can DDI actually work operationally based on the constraints of your particular project? So how do you figure this out? You use the right tool and technique for simulation. Smith did a great job in his presentation and in the Q&A talking about this, so I'm not going to go into this further. But I do want to talk a little bit about the geometry playing a major role. Spacing between the crossovers is important for the operations. Number of lanes possible on or below the structure. Can we narrow the lanes, or can we add another lane possibly? Coordination with the other signals and the driveways. And you see here, this is the project 22 and 145, where we couldn't touch the existing bridge, and there's only 6 lanes going across right now, and we have 2 sidewalks, and we were able to get 7 lanes on the bridge with 1 sidewalk by reducing the lane width from 12 feet to 11 feet, and by transitioning it properly to the crossovers and the reverse curves to make sure that we can get trucks and other vehicles to stay in their alignment. We were able to play with geometry to get more lanes, and now we can get 3 through lanes now in the south direction. We can get 4 through lanes in the north direction, where currently there's only 2 through lanes in each direction. Can DDI fit in a tight context? Well, usually we can, but it may not be the optimal design from the guide, and that's where things get kind of tricky. So we got to do what we might call "quote unquote" suboptimal. And you might say, well, it's suboptimal, we can't do that. But the truth is that the DDI will probably be significantly safer than the alternative. Just because the DDI, we've seen several safety studies now, that DDI reduces crashes by 35% compared to simple diamonds and reduces injury crashes by 65%. And these studies included both optimal and suboptimal DDIs. So we know that DDIs are going to reduce crashes. If we need to go somewhat suboptimal, it may or may not have an effect on safety. If we design it correctly, it probably will not have an effect on safety. So some of these quote unquote suboptimal things we can do is reduce speeds, we can reduce the crossover angles, have asymmetric DDIs, and we can also have suboptimal bike paths. So you see an example here on the right where we had to fit the DDI underneath the bridge. This is the one just northwest of Reading on Broadcasting Road. And we were still able to maintain 2 lanes each direction, and we were able to put in a 7-foot wide bicycle / pedestrian facility in the median. Now, ideally, optimal would be 10-foot minimum, but 7 foot still works. And so you still get a lot of value over here by, even though it's not optimal, you still get a solution over here. Crossover angles. I know Smith and I have both talked about this, that the most important element is not really the crossover angle, but it's really the direct path between the through movements where you might get a wrong way movement. And we actually now have some research that proves that. So really, that crossover angle does not have to be 45 degrees like it says in the DDI book, and it will actually, that element will be eliminated hopefully from the next guide based on the preview I've seen so far. But also keep in mind too that we also talk about the eyebrow, which is the angle that is for the through movements, but we also need to worry about the direct path for the ramps and make sure those ramps, that traffic cannot get to the opposite direction and cause a wrong-way crash. How should ramps be designed? Well, the answer is really different depending on the off-ramp and the on-ramp. For the off-ramp, the main concern really is the clearance of vehicles and bicycles. But for the on-ramp, the concern is mainly the queues from the crossover blocking the ramp access. So you see here, this is the DDI in Kentucky, where you see that the off-ramps are coming right next to the crossover. And this is a really nice design. We really wanted to minimize that distance so that we don't have that major clearance time that Smith showed that is sometimes necessary on some DDIs. If we can minimize that through geometry, that's great. We can't always do that, and if you had to choose one or the other being close to the crossover, I would choose the right turn ramp. And the reason for that is that bicycles and pedestrians need to cross on the near side of the ramp as well. And for that clearance time, you want to have that as close as possible to the crossover. And if you're going inbound into the DDI towards the bridges, the bicycles and the pedestrians, if they're on the in the median, they'll be towards the center. So the ramp traffic making a left turn will not be close to the pedestrians' bicycles. Now for the on-ramps, it's the opposite. If you're having traffic peeling off of a lane to go to those on-ramps, you want to kind of lengthen that distance as much as possible so that queues don't back up and block the access to the ramps. Because that causes both operational and safety problems if you do that. What about seismic crashes? How can we minimize that? So the answer is really to reduce the need to change lanes, and you do that through signing and proper striping and designing properly for the signing. And then you also want to maintain the vehicles in the proper lanes through the curves and turns. Now, why am I isolating seismic crashes? The reason why is that DDIs, pretty much by itself through the design, they not eliminate, but they reduce crashes, the overall crashes, the end crashes, the rear end crashes significantly, almost no matter what you do. But seismic crashes is a different issue. Overall, in the study done that was published in 2019 by Nye, he looked at 26 DDIs, and he saw that for seismic crashes, the CMF was actually above 1.14. Now, of the 26 DDIs, 14 of them actually had CMFs below 1. So that shows you that if you do design nicely, you can get side swipes reduced as well in DDIs. But of the remaining 12 DDIs that had side swipes over 1, which means that you had more crashes in a DDI than you would in a standard diamond interchange. 4 of those DDIs had a CMF of over 2. And here's one example. This is an example of one of the first DDIs built in the country. This was in New York, where the sinusoid speed in F was about 2.2. So that's what we're saying is that you may have a 220% increase in crashes, sinusoid crashes of this DDI compared to if this was a diamond interchange. And you can see the reason why this probably happens is that there's pretty much no geometry at the crossover. You basically have to make a very sharp turn into the crossover and then a very sharp turn again outside the crossover. And so there's a lot of sinusoid crashes over here. So if we can design properly to avoid sinusoid crashes, these CMS for overall CMS will probably reduce more than just 0.63, probably reduced maybe another 5–10%. So, do DDIs always need to be one bridge? This was a question that came up on the Cloverleaf DDI project in Southwest Pennsylvania on I-70, and the answer is that no, you don't need one bridge for DDI. If we're building new structures, 2 bridges are often more preferable. You get nice advantages with 2 bridges because you have better crossover design, better intersection sighted from off ramps, more flexibility in the design, and you have easier maintenance of traffic during the design. So 2 bridges is better than one if you can get it. Doesn't mean one bridge won't work, and if your constraints require one bridge, that's perfectly fine. But if you have the choice, if you have the option of 2 bridges versus 1, 2 bridges will often be better, and usually will not be much, if any, of a cost increase. How should DDIs be signed? This is probably the biggest research gap we have in DDIs. It's not definitive yet, and we've been doing many different things, and it often depends on context. You can see in the picture up here that this is a location where the signing is for 15, but you're not necessarily understanding what's happening for the through movement. And so when you sign it like this, sometimes you can get lane imbalance, and that's not often shown in your simulations. So make sure when you design DDI, design it so you can sign it. And you got to really look at this really early. Look at your signing really early. It could affect how you design your DDIs. Here are more examples of signing. There's actually a lot of different examples, but I'm not going to have enough time to go through them all. There's a lot of information that's happening in the DDIs that you need to convey to the driver. You need to convey it before they go through the reverse curves, because once drivers go through curves, they're paying more attention to the words of the signs. So you got to get in the proper lane before they start entering these curves. How should DDIs be designed when you have horizontal curves? And the basic answer is to treat them as one-way streets when you can, and don't worry about symmetry. You can see here a difference between the top and the bottom. Here on the top, you have one bridge, and you have all these reverse curves. It's kind of like you're going through a roller coaster as a driver getting through the DDI. But it was designed with the center line in mind. But if you look at the one to the south, in Utah, you see that the one-way alignments were designed separately, and you can get much smoother alignments through here. And the last thing is, where should pedestrians crossings be located? There really needs to be a balance between where the pedestrians want to go and the designing of the desire line safely. This is something that I worked on the for the new guide for the pedestrian bicycles. And the first thing that we really want to do is make sure you have proper sight distance. We see too many crossings. So this is not just DDIs. This is all over the place for other interchanges and intersections where you just can't see what the incoming traffic is coming, or the driver coming in there can't see the pedestrian. So you first have to make sure that you have proper sight distance. Then you want to make sure that you're designing so that you go through, so the pedestrians going the way they want to go. And I didn't mean to pick on Smith, because I think this is Smith's project. But in this project, you have a zigzag movement for the pedestrian when the pedestrian really wants to go straight. So if you play around with the design a little bit and understand that the pedestrian will probably go straight, even though you designed it for the zigzag, a lot of pedestrians will probably just ignore that. If they feel like they can go safely across, they will. And really, you're only adding maybe a second of the crossing, and these crossings are controlled. So I prefer more like this design, where this is in Kansas, where you have a direct crossing all the way across The ramp for the right turn is very close to the crossover, and so you can get directly across over here. For an uncontrolled crossing, you want the speeds to be very low at the crossing. So I think this design is a great design over here. This is Row and in Kansas. So lessons learned, basically, the DDI design, many of the elements are not in the informational guide. Copying and pasting from the guide or built DDIs, maybe repeating the same mistakes. Some of these answers are going to be shown in the second edition of the Federal Highway Guide, but it'll still only be a starting point. So these peer reviews are really valuable to help you with for information that's not in the Federal Highway Guide, and can really be valuable during the beginning phase, during the ICE process of planning, to get you started to see if the DI is the right solution, and it's very valuable in the later phases to make sure that you design the detail safely. I'll take questions, or if there's any chance for questions.
Yeah, thanks, Gil. Really some good lessons learned and some nice design and geometric and operational discussions here. Gil, can you go back to your slide real quick? I want to ask one question before they cut us off here. You had this, it was the side swipe slide, and I think it's, you mentioned the crossover angles and not necessarily being a hard criteria anymore. And can you go back to the side swipe slide and give us re-explain maybe curvature and the cars are going through the crossover? I felt like that could use it'd be nice to clarify because at the end of the day, we want nice natural driving paths, and then we also want people not have the ability to go the wrong way down the crossover. So I had a hard time visualizing, I guess, the why the side swipes were occurring in the example project.
So in this example over here, we don't have reverse curves. It's very tight to get through the crossovers in this DDI New York. So when you're coming, let's say you're going up here as a driver, you get to that crossover and you're very quickly curving to the right and then very quickly curving to the left. And to maintain the lane in that situation is very difficult. So we see in many DDIs that are designed well, we have wider lanes with the crossover. We have curves that are well designed so that you can maintain your lanes. And it's not just through the crossover, but it's also from the ramps, making the left turn or the right turn into the arterial. You want to make sure that there's design, your design vehicle is able to maintain the lane so that we don't cross into different lanes and then sideswipe. The other issue for sideswipes is when your signing is poor, you have more changing of lanes, and that in general, just having the increase in lane changes will increase sideswipes.
Right. Great. Well, I think they let us go over here by 3 or 4 minutes. So if anyone else has any additional questions, as the chat box says, please email them. I know Smith and Gil and Dave would be more than happy to answer any more questions. This was a really great session. I really wanted it to be informative, and I think that we achieved that. So thank you so much, everybody, for attending, and great presentations all around. So with that, I wanted to say thanks and enjoy the rest of the conference.
Thank you.
Thank you.
Thanks. Take care.